in this video, we're going to continue topic 10.13, talking about intervals and radius of convergence. And we are looking at example 3C, where we're looking to see if our endpoints are included in our interval. I'm going to start again with a ratio test. So I'm going to look at the limit as n approaches infinity. I'm going to substitute in the n plus 1 anytime I see an n. So x to the n plus 1 over n plus 1 squared. And I'm going to divide by the original or multiply by its reciprocal. And I'm going to go ahead and rearrange a little bit and then take some things apart. So I know I can take the x to the n plus 1 apart as x to the n times x times n squared over, I'm going to move this other x to the n up front, and then n plus 1 squared to the back. I know my x to the n's cancel. And then we have the limit as n approaches infinity of x times n squared over n plus 1 squared. Since even if I FOIL this out, I know my highest exponent is going to be a 2, so I'm just going to look at the limit in front, which is 1. So my limit is actually just going to be the absolute value of x. We want to force it to be less than 1, which means that implies that our interval is going to be between -1 and 1. So I want to take that interval and I want to test each of the endpoints to see if they are included. So I'm going to test back into my original series. So when x is equal to -1, we would have -1 to the n over n squared, the sum as n equals 1 to infinity, of course. And if I look at that, all right, sorry about the pause. I just had to look. I wasn't understanding my notes for just a second there. All right, so we've got -1 to the n. So I would probably use my alternating series test on this. So I'm going to say that I'm going to look at my terms. So again, I just look at to see what the limit as n approaches infinity of 1 over n squared. So I notice that that's 1 over infinity squared, which is in fact going to be 0. So condition 1 is met. Condition 2 is I have to have decreasing terms. So 1 over 1. 1 over, I put a 2 and I get 4. 1 over, put a 3 and I get 9. So I'm pretty sure those are decreasing. So therefore it converges by alternating series test, which means that this one is going to be included. So it'd be a less than or equal to. And then we're going to look at the other endpoint, which is the sum as n equals 1 to infinity. So this would be for x equal to 1. So for 1 to the n over n squared, which is really just the same as saying we'd have 1 over n squared, which we know that that's a p series with p equal to 2. And when p is greater than 1, so if I go back up, I think I have my chart here somewhere. If I go back up and I look at my chart, when p is greater than 1, it converges. So therefore it converges. Converges by p series. So officially this would also be equal to. So my official interval of convergence would be between -1 and 1, both endpoints included.